Hello everyone, I'm Dr. Prasad Puthiyillam, continuing my class series on chemistry for computer science and engineering, VTU Technological University for the new scheme 2023 or 22-23 released this new scheme, new subject code BCHES102 for first semester and BCHES 202 for second year. Only for computer science and engineering I will be covering the classes for electronics and communication, mechanical stream as well as civil stream classes in my coming days. So first preference is given to computer science engineering only because many are the computer science engineers for my YouTube channel to view. Okay, so I already almost covered half of the module 1. Previous class I covered electrochemical gas sensor for oxides of sulfur. This video I'm covering electrochemical gas sensor for oxides of nitrogen. Next one, that is disposable sensors. Okay, so syllabus is given there. Only the syllabus scheme was changed. The syllabus did not change recently. Okay, so this year it was changed, but very recently the subject code got changed to BCHES102. Electrochemical gases for oxides of nitrogen. So some of the important questions. Taking only the level 4 questions so that it will be useful for the students for the future. Anyhow, the topics will be covering the general basic information as well as little bit high-end information giving in this YouTube channel. So first question, compare and contrast the reaction mechanism of different materials commonly used for oxides of nitrogen detection in electrochemical gas sensors. Evaluate the effectiveness of different electrode materials in electrochemical gas sensor for oxides of nitrogen detection. How can the electrode composition, sensing material morphology and electrolyte composition be manipulated to enhance the performance of electrochemical gas sensor for oxides of nitrogen detection? I like this question. Analyze the chemical properties of different sensing materials that can affect the selectivity and sensitivity of electrochemical gas sensor for oxides of nitrogen detection. Evaluate the impact of environmental factors such as temperature and humidity on the performance of electrochemical gas sensor for oxides of nitrogen detection. Evaluate the limitations of using electrochemical gas sensor for oxides of nitrogen detection in real world applications. Compare and contrast electrochemical oxides of nitrogen sensor with the other types of gas sensors in terms of their performance and applications. Develop a strategy. Still questions are coming, that means it will be a lengthy video. Please be with me, bear with me. You can pause and watch whenever you want, but I need to record it in a continuous mode. Develop a strategy for improving the performance and durability of electrochemical gas sensor for oxides of nitrogen detection. Consider factors such as electrode material, sensing material morphology and environmental conditions. How does the chemistry of the sensing material influence the selectivity and sensitivity of electrochemical gas sensor for oxides of nitrogen, and what are some common materials used for oxides of nitrogen detection? Discuss the principles underlying the design and optimization of electrochemical gas sensor for avoid noise detection, and explain the role of various parameters such as electrode composition, sensing material morphology, electrolyte composition in influencing the sensor performance. It's just like when we watch a movie, initially we'll be giving who are the main character, who did the character, who did all the different activities to get the video, like that. First given some 10 to 15 questions, we can pass forward it and reach to the topic chemistry and properties of oxides of nitrogen. They refers to the highly reactive gases including the nitric oxide and nitrogen dioxide, NO as well as NO2. Continuing that, the gases are formed during high temperature combustion process such as in power plants, automobiles and industrial processes. Oxides of nitrogen emission are a significant contributor to the air pollution and can have adverse effect on human health, including respiratory issues and cardiovascular diseases. Respiratory means through the respiratory channel, cardiovascular is something related to heart. Chemically, nitric oxide is a colorless, odorless gas. Odorless means no smell, and that is highly reactive and unstable. It is a free radical with unpaired electron, making it highly reactive with other molecules. It is a odorless gas. We cannot sense with our nose, so we need a sensor for that. Our sensor is not sufficient. Our nose is one of the very good sensor. That's what I want to say. Nitrogen dioxide NO2 is a brownish red gas that has a pungent odor. Okay, can be detected. It is also highly reactive and can react with other atmospheric gases to form secondary pollutants like ozone. Ozone is good for not to our level, high level. That means the ozone layer, if it is there, good, not to the height that we are taking the oxygen. We don't want ozone, we need only oxygen. Too much oxygen is not needed. Means 3 oxygen is not needed, we need 2 oxygen. O2 is good, O3 is not good. NOx compounds are formed during the combustion of fossil fuels in the presence of oxygen and nitrogen. The high temperature in these combustion processes cause the nitrogen and oxygen molecule in the air to react and form oxides of nitrogen. Simple sentences. The amount of oxides of nitrogen produced depends on the type of fuel used, the temperature of combustion, and the amount of oxygen available. Nitric oxide NO is a relatively stable molecule and has a lower toxicity than nitrogen dioxide, which is more reactive and can be harmful to human health at high concentrations. Oxides of nitrogen compounds also play a role in atmospheric chemistry, contributing to the formation of acid rain and ozone in the lower atmosphere. Lower atmosphere, ozone is not good. Electrochemical gas sensor for NOx, its introduction. Earlier slide, it was only chemistry and properties. What is electrochemical gas sensors? Because to monitor the oxides of nitrogen, many different methods are used. Electrochemical gas sensor is one of the method. It operates based on the principle of electrochemistry. Electrochemistry means the chemistry is there, then electron movement is also there. Then we call it as electrochemistry. Chemistry means some reactions happens, usually redox reactions, where chemical reactions involving the oxidation occurs at the electrode surface. The reaction happens at the electrode surface and produces a signal. Measurable electrical signal is produced. Electrochemical oxides of nitrogen sensor typically consist of a sensing electrode and a counter electrode immersed in an electrolyte solution. That means it has got a electrode, electrode, a rod, then some electrolyte, another rod to detect. Therefore, it will sense electrolyte changes. It gives the other electrode to have the changes, which are counter electrode is the reference electrode is the connected to circuit, will give the read signal. The sensing electrode is coated with a material that selectively reacts with the oxides of nitrogen gas of interest, while the counter electrode completes the electrical circuit. I think I didn't add that image here. Just check my previous videos so that I put that general schematic representation of electrical gas sensor. Okay, so schematically same, but based on the material used, based on the different applications, the design will be different, but the general uh, basic design is the same. The electrochemical reaction at the sensing electrode produces a measurable current which is proportional to the concentration of the oxide NOx gas in the surrounding environment. So you may be asking how to get your previous videos. At the end of this video, I will give the link of my YouTube channel, the playlist where only the chemistry, engineering chemistry videos are there. From there you can select it. You kept a module 1, part 1, part 2, part 3, part 4, part 6, and this is part 7. Okay, so there are different types of electrochemical NOx sensors, which include amperometric sensors and potentiometric sensors. So what is amperometric, what are potentiometric, that are explained in detail in my previous classes. Amperometric sensor are used for NOx detection. Potentiometric sensors are also used. What are amperometric sensors? They measure the current generated by the electrochemical reaction, while potentiometric sensor measure the potential difference between the sensing and counter electrode. Okay, both types of sensors have their advantages and disadvantages depending on the specific application requirements. Some common materials used and the reaction involved. When reaction comes, so we chemistry people feel very proud. Okay, I am, my background is chemistry. I'm applied chemistry. I studied applied chemistry. So tungsten trioxide chemistry is the metal oxide sensing material. It reacts with the oxides of nitrogen gas, which can be represented as 2NO2 plus 2 electron gives 2NO2 negative charge is there on that. Okay, that is adsorbed. It is getting adsorbed in the in that form to the sensing material, and it reacts with the sensing material. If it is tungsten trioxide, that is it reacts with NO2 minus in presence of oxygen and little bit moisture present there, that is water molecule, to become H2WO4, and nitrate ion is formed, which can be easily measured. It increases the conductivity. If zinc oxide material is used, then a reaction can be represented as follows: NO2 plus 2E minus gives NO2 minus, again same reaction, adsorbed on the sensing material, and it reacts with the sensing material ZNO plus 4 NO2 minus in presence of moisture gives zinc NO2 NO3 twice. Zinc nitrate and hydroxide ions are formed. So here also it generates both cases the electrochemical reaction generates a measurable electrical signal which is proportional to the concentration of nitrogen dioxide gas present in the surrounding environment. Other electrodes materials like graphene, it is a highly conductive material and high surface area is there, and it is very selective to absorb NO2 gas. Therefore, it will also will produces measurable changes in electrical conductivity, which is proportional to concentration of the gas. And metal organic frameworks. Actually, in previous class video, I introduced the metal framework. I know that in this I'm explaining in detail. So here I'm giving some examples also. Metal organic frameworks. They are porous material. Pores are there in the material. That is the meaning of pores. Porous material. It also will it is also used as a sensor for some examples. MOF5 is one of the most well-known metal organic framework. It consists of zinc ions coordinated with terephthalic acid ligands. Okay, so chemistry people know about what is the coordination bond. Okay, so zinc ions having the coordination bond with the terephthalic acid ligands, and we also know what are ligands. Ligands are having many reactive sites. Okay, something. Okay, the engineering students are coming and may not be learned in detail about ligands and all, but they know what is ligand, but they know what is coordination bond. So just you understand that zinc ions are the covering the terephthalic acid molecules that work together as a metal organic framework. Okay, so metal is there, that is zinc, organic molecule, that is terephthalic acid. Therefore, the name metal organic framework. Another example, HKUST1. This consists of copper ions having in coordination with 135 benzene tricarboxylic acid ligands. Another example, MIL101. This is composed of iron ions coordinated with the terephthalic acid ligands. So what we need to say that zinc ions can be used along with terephthalic acid, iron ion can be used along with terephthalic acid, copper ions can also be used with other organic molecule. Zirconium ions, these are metals. Zirconium ions can also be coordinated with 1,4-benzene dicarboxylic acid ligands. Some few examples which are used or introduced by the scientist, which I searched and found and put here. The working principle of electrochemical gas sensor for NOx is based on the electrochemical reaction that occurs at the sensing electrode when it comes into contact with the NOx gas of interest. That means the NOx, either NO2 or NO, it should come and sit on that sensing material then only the reaction takes place, then only we'll get the result. So the reaction produces an electrical signal that is proportional to the concentration of the gas in the surrounding environment. The sensing electrode of an electrochemical sensor is typically made of material that selectively reacts with the gas of interest. The most common sensing material for NOx or tin oxide. Then the sensing electrode comes in contact with the NOx gas. The gas molecule adsorb onto the surface of the electrode and react with the sensing material. The reaction generates an electrical current which can be measured and used to determine the concentration of the gas in the surrounding environment. The counter electrode of the electrochemical sensor, it completes the electrical circuit by allowing the current to flow back to the power supply, completing the circuit. And the electrolyte solution between the sensing and counter electrode allows for the transfer of ions and electrons between the two electrodes. So I just roughly draw a sensor here because too much explanation is given without visualization is not good. So I'll try to draw. I'm just searching for the pen option. I think I got one pen option. Okay, so I'm considering this as a membrane in an electrical sensor, which is having a coating of the material which we use. Okay, give me time to draw it. I'm not good with drawing with the mouse. Okay, so this is kept inside a chamber. Okay, so this is the chamber. Okay, this is a chamber containing electrolyte here. So these dot represents electrolyte. Okay, too much electrolyte. So these represents the gas molecule, not this much bigger size, simply representing. Okay, the gas molecule is bigger than the sensor. Okay, so gas molecules are very small gas molecules present there. This is a membrane. This is the electrode made up of mainly platinum or a gold, which is coated with the sensing material, which are the lead oxide or tin oxide or tungsten oxide, tungsten trioxide. Then a suitable electrolyte also we need to consider based on the material that we use, which has got a now connected to a counter electrode, then a reference electrode. So two more electrodes I drawn here. Electrode means metal. Okay, these are connected externally. So the counter electrode, reference electrode, these are connected externally to get a reading. Okay, I'll write reading. Better to not write reading. READING. So we'll be getting the reading connecting to my handwriting. Very good handwriting. G is very excellent. Okay, so we should have a temperature sensor also. So this is the basic setup which I am explaining, which is explained here. It has got a sensing electrode, it has got an electrolyte, it has got a counter electrode. So this one which is the counter electrode, I think the mouse option is there. Okay, you can see. I'll come back to the mouse screen, back screen, back screen, right screen. Pointer option coming out to arrow. Okay, okay, so this is the counter electrode. This one is the reference electrode, this is the working electrode. So three electrodes are the electrolyte is there. So when gas molecule of our target come in contact with the sensing material, reaction takes place, which will go through the electrolyte. The reaction moment takes place, which will be sensed by the counter electrode. With reference to the reference electrode, we'll get a reading which is equivalent, or which is with that reading we can say how much gas was there present in that atmosphere. Okay, so counter electrode allows for the transfer of ions electrons between these two electrodes. Next, overall, electrochemical gas sensor for oxides of nitrogen offer a reliable and sensitive method for detecting and measuring the concentration of the gas present in the various industrial and environmental applications. Their selective sensing mechanism and real-time response make them a valuable tool for monitoring and controlling oxides of nitrogen emission. The principle underlying the design and optimization of electrochemical gas sensor need to be explained. So the principle underlying the design and optimization of electrochemical gas sensor, we need to consider sensing material selection. The choice of sensing material is very critical in the performance of an electrochemical oxides of nitrogen sensor. The sensing material should have a high sensitivity and selectivity to oxides of nitrogen gases and a low cross sensitivity to other gases that may be present in the environment. The material should also be stable, reproducible, and have a fast response and a recovery time. And the second point, that is electrode design. The design of the electrode is important in determining the sensitivity and selectivity of the sensor. The electrodes should be designed to provide high surface area, promote efficient mass transfer of the gas to the sensing material, and minimize the interference from other gases. Sample pre-treatment, another criteria. The sensor's performance can be affected by the presence of interfering species or humidity and temperature in the environment. Sample pre-treatment techniques such as the filtering, temperature and humidity control, it can be used to minimize any interference from these factors. Signal amplification. The signal generated by the sensor can be amplified using techniques such as impedance spectroscopy, chronoamperometry, and cyclic voltammetry, so that we'll get very good results. Even though the gas present is very less, more signal will be produced. It can be amplified. These techniques can increase the sensitivity and selectivity of sensor and improve the detection limit. Calibration and validation. The sensor should be calibrated using a non-concentration of oxides of nitrogen gases to determine its response characteristics. Validation testing should also be carried out under a range of environmental conditions to ensure that the sensor meets the required performance specifications. Miniaturization and integration. Miniaturization means bringing to smaller size, miniature size, something related to smaller size. Integration means connecting some other component, other sensors or other devices along with the gas sensor. Miniaturization and integration of the sensor with electronics can improve its portability, sensitivity, and ease of use. Miniaturization means it becomes smaller size so that we can carry. Portability is good. The sensitivity also will be good, and usage also very effective. This can be achieved by using microfabrication techniques such as photolithography and micro machining. This mainly after the introduction of nano material, nanotechnology, many methods are introduced like photolithography, micro machining. It can be used for material preparation, the sample preparation, the sensor preparation, the sensing material preparation, or the electrode preparation. The decision and the design, not decision, the design and optimization of electrochemical gas sensor for oxides of nitrogen detection requires a multidisciplinary approach that involves material science, electrochemistry, electronics engineering. By optimizing these parameters, electrochemical gas sensor can be developed with high sensitivity, selectivity, and high reliability, making them suitable for a wide range of applications. The sixth point, the role of electrode composition, sensing material morphology, and electrolyte composition in influencing the sensor performance. Electrode composition. So, the topic is role of electrode composition, sensing material morphology, electrolyte composition, and how they influence the performance of the sensor. Electrode composition. The choice of electrode composition can impact the sensitivity and selectivity of the sensor. The electrode should have high electrical conductivity and high surface area to promote efficient mass transfer of the gas to the sensing material. The use of noble metals such as platinum and gold as electrode material can improve the sensor sensitivity, but they can be expensive. Platinum and gold are expensive. You know why it is expensive. Avoid that habit of purchasing gold and platinum ornaments. Give it back. Make it use as electrode. We can sense the oxides of nitrogen at least. Therefore, other materials like carbon-based electrodes and metal oxide-based electrodes are also used in electrochemical sensors. Okay, alternates are there, so no need to worry. Carbon-based electrodes are used. We can simply use the soot carbon can be used in the form of graphite or graphene or any other related carbon-based materials that we study fullerene, etc. Sensing materials morphology. How morphology? The morphology of the sensing material can impact the sensitivity, the selectivity, and response time of the sensor. Morphology means the surface property, not the again previous class also I explained the same thing. Morphology means if you want to take a surface, you got to go zoom. We need to go inside. That means we need optic microscopes needed. Micro level, micron level, or nano level, we should reach the size. Then there whatever very smooth items what is seen to us may not be smooth. We can see different ups and downs. Therefore, that will affect the sensing because the molecule that you want to sense, that oxides of nitrogen, they are very small in size. Therefore, it will affect the uh, sensing. Just like if you want to play cricket, we need a playground, not a hilly area. For oxides of nitrogen, if the morphology is not good, means it cannot play properly. The reaction cannot be done. Reaction cannot may not happen in a fast mode. Therefore, it affects the response time of the sensor. The sensing material should be in a form that promotes efficient gas absorption and desorption. Adsorption means going and attaching to the surface. Desorption is going away from that. Nanostructured sensing materials with high surface area to volume ratio can improve the sensor's sensitivity and response time. High surface to area volume ratio now is a very common usage. Everyone knows. I am not explaining it. Many years I am explaining the same thing. You just check what is a high surface to area to volume ratio. For example, the nanostructured metal oxides like tin oxide, zinc oxide, tungsten trioxide have been shown to exhibit high sensitivity and selectivity to oxides of nitrogen gases. Electrolyte composition. The electrolyte composition can also affect the sensor's performance. The electrolyte should be stable and non-reactive with the sensing material, and it should provide sufficient ionic conductivity to facilitate charge transfer between the electrodes. Electrolyte composition continuing. The pH of the electrolyte can also affect the sensor's performance since it can influence the adsorption and desorption of the gas on the sensing material. So we have to consider the hydrogen concentration in the electrolyte also, hydrogen ion concentration. For example, acidic electrolytes can promote the adsorption of oxides of nitrogen gases on metal oxide based sensing material, while basic electrolytes can promote its desorption. Okay, oxide, if acidic condition is there, the oxide will come and attach to that. If it is alkaline condition, then easily it can be removed. Optimization Optimizing these parameters is very critical for the development of a highly sensitive and selective electrochemical sensor for oxides of nitrogen detection. By selecting the appropriate electrode composition, sensing material morphology, and electrolyte composition, the sensor's performance can be enhanced, leading to improved accuracy and reliability in oxides of nitrogen gas detection. Seventh point, there are many points on there. The chemistry of the sensing material that influence the selectivity and sensitivity. What is the chemistry behind that? Why it is influencing? The chemistry of the sensing material is critical to selectivity and sensitivity of electrochemical gas sensor for oxides of nitrogen detection. The sensing material should have the ability to interact with oxides of nitrogen gas in a specific way, leading to changes in the electric conductivity or potential of the material. Simply reading, let's check previous one. Chemistry of sensing material is very critical. Okay, it's very critical. You should know the chemistry behind the material that we use for sensing should have a very good interaction with the target, that is oxides of nitrogen, in a very specific way. That is a very good challenge for us to get a better electrical conductivity or potential of the material. Here are some chemical processes which influence the selectivity and sensitivity of electrochemical gas sensor for oxides of nitrogen. Some chemical processes are given. Redox reaction, oxidation, reduction combined. Many sensing materials undergo redox reaction uh, when they come in contact with oxides of nitrogen gases. For example, metal oxides like tin oxide, zinc oxide, and tungsten oxide, it can be oxidized. Okay, these materials, this sensing material will be oxidized if NO2 comes, and NO2 getting reduced to NO, nitrogen monoxide, leading to the changes in their electrical conductivity. The magnitude of the change in conductivity depends upon the specific metal oxide and concentration of the oxides of nitrogen gases in the environment. Second, acid-base reactions. Acid-base reactions, very good one. It can also influence the selectivity and the sensitivity of electrochemical sensor for oxides of nitrogen. For example, NO2, nitrogen dioxide, it can react with the water vapor to form a nitric acid. Okay, NO2 plus H2O gives HNO3. That we know, which can further react with the metal oxides like zinc oxide or tungsten oxide, trioxide to form nitrate ions. So nitrate ions, then conductivity changes. These reactions can change the pH of the sensing material and alter its electrical potential. Surface reactions. Surface reactions can also play a role in the selectivity and sensitivity of electrochemical sensors. For example, NOx gases can absorb onto the surface of the sensing material, leading to changes in the electric conductivity. How fast it getting absorbed, that is the concept of surface reaction. The magnitude of the change in the conductivity depends upon the specific surface area and the surface chemistry of the sensing material. How fast it absorbed, what are the additional functional group present which will attract or which will hold the oxides of nitrogen. These are comes under surface reactions. Catalytic reactions. Some sensing materials can act as catalyst for the oxidation or reduction of oxides of nitrogen gases. For example, platinum, palladium are commonly used as sensing material in electrochemical sensor for oxides of nitrogen due to their ability to catalyze the oxidation of NO to NO2. If they are getting converted, then accordingly the sensing material undergo oxidation, then reduction, then it can be measured. The factors that can affect the sensor performance. First one, temperature. Electrochemical sensors operate within a specific temperature range, and deviations from this range can affect their sensitivity and response time. Therefore, always you should have a temperature sensor along with the gas sensor. High temperatures can lead to increased oxidation of the sensing material, leading to reduced sensor lifetime and accuracy. On the other hand, low temperatures can lead to slower reactions and reduced sensitivity. Humidity. The presence of moisture can affect the selectivity and sensitivity of electrochemical NOx sensor, because the water molecule, water gas as a gas, it will also will react and produces the signal. So it will affect humidity, also will affect. High humidity can interfere with the gas absorption and desorption, also leading to reduced sensor response. The sensing material can also react with moisture, leading to chemical changes that can affect its performance. Interference gases. Electrochemical NOx sensors can be sensitive to other gases present in the environment, leading to the false positive or false negative results. Other gases will interfere. For example, sensing material that react with reducing gases like carbon monoxide, H2. Okay, by mistake I didn't make it smaller. This one should not write H2 like this. Hydrogen gas it is a capital letter and to the subscript. Exhibit reduces sensitivity to NOx gases. Therefore, it is essential to minimize the interference of other gases to improve the selectivity and sensitivity of the sensor. Electrode and sensing material degradation. Okay, degradation, corrosion, all those are considered. Over time, the electrodes and sensing material in electrochemical and sensor can degrade due to exposure to environment, leading to reduced sensor performances. Oxidation, reduction, and other chemical reaction can lead to changes in the sensing material structure, electrical properties, leading to reduced sensitivity and accuracy of the electrode. Electrolyte composition. What is the composition of electrolyte also will affect the sensor performance. The electrolyte in electrochemical NOx sensor can affect the sensor performance by influencing charge transfer between the electrodes. The electrolyte should be stable and non-reactive with the sensing material, and it should provide sufficient ionic conductivity to facilitate the charge transfer. Changes in the electrolyte composition can lead to changes in the sensor's response. Simple sentences. The advantages of using electrochemical gas sensors. A high sensitivity is electrochemical gas sensors are capable of detecting a noise at very low concentration, typically in the parts per million ppb or parts per million ppm range, making them highly sensitive. The selectivity is good. The electrochemical sensor can be designed to be highly selective to a specific gas such as a noise while minimizing the response to other gases in the environment. Fast response time is quickly it will give the result. Response is good. Electrochemical gas sensors can provide near real-time monitoring of noise concentration, making them ideal for applications where rapid response is important. Low power consumption. It takes very low power, power. Therefore, it can be very useful as a portable devices. It can be used with battery powered, no need of normal AC current. Long-term stability is there. Electrochemical sensors are known for their long-term stability and reliability, making them suitable for continuous monitoring and application. Continuous monitoring applications. Low cost. They have very low cost compared to many other sensors. The electrochemical gas sensors, they offer many advantages for the detection of noise, making them a popular choice for a wide range of applications, including air quality monitoring, industrial emissions monitoring, and automotive exhaust gas monitoring. The limitations, the same will come as limitation. Cross sensitivity. Cross sensitivity means it will react with other gases, interfering gases. That is called as the cross sensitivity. Not so perfectly, it's not so perfect. Our present NOx sensors are not so perfect even now. It reacts with other gases. It has got a limited range. A very high concentration or very low concentration cannot be measured. It's in the ppb or ppm. That may not be sufficient for some applications. Calibration need to be done continuously, so it takes time and time consuming and specialized equipments needed to calibrate it. Even manpower also may be needed sometimes to do the calibration in a period of time. Repeated calibration needed. Drift velocity. Drift is the over time the electrochemical sensor can experience drift in their baseline reading, which can result in inaccurate measurement if not properly monitored or corrected. That means if you keep the sensor for a long time, the some base value that we might have kept that will be varying slowly. That is known as drift. Environmental factors which are affecting, they are affecting. So one of the limitation like humidity, pressure, high impact on the accuracy and the reliability. the lifespan have limited lifespan. The electrochemical gas sensors are not cannot be we are not using for long time because of some of the limitations. Lifespan is less. Now let us compare electrochemical NOx sensor to other type of gas sensors. There are several types electrochemical sensor, one of the type that we are discussing now, metal oxide sensors, catalytic sensors, optical sensors. Three more types are there mainly. So there are advantages and limitations and comparison it is given here. Some comparison are given the next slide. That is metal oxide sensors. They are commonly used for detecting oxides of nitrogen in very low cost portable applications, normal persons applications. Very not so just we want to detect whether oxides of nitrogen is there or not. No, not much worried about exact concentration and all. Then metal oxide sensors are sufficient. They operate by detecting the changes in the electrical conductivity caused by the presence of NOx. It can be less selective, they are less sensitive than our electrochemical sensor of that what we are discussing now. Electrochemical sensors are far better than metal oxide sensors. Catalytic sensors are the separate category, separate sensor, separate concept. They convert the catalytic to convert NOx into either another signal or convert into heat or electrical signal. They are highly sensitive and selective to NOx, but they can be expensive and may require frequent calibration and maintenance. Highly sensitive sensor, we cannot normally use it. Therefore, exact measurement, almost exact measurement, better than electrochemical, but very costly and maintenance is also difficult. Optical sensors are they use light to detect the changes in the concentration of NOx. Highly selective and can be very sensitive, but they are very expensive and require the continuous calibration and maintenance. Improving the performance of and the durability. Material selection is one of the criteria. Choose a material with a high stability and selectivity towards NOx sensing. For instance, electrometal like platinum, palladium, they are highly selective. Other materials are graphene oxide, metal organic framework, nanomaterials are as used. Electrode design has to be proper with a high larger surface area so that sensitivity will be good. Nanoparticle based electrodes can increase the surface area and sensitivity can be improved. Proper calibration needed, regularly calibration needed so to get accuracy and reliable detection. The only calibration can correct any possible drift in the sensor and give more lifetime to the sensor. Temperature control is very important because it is something we are dealing is gas, some pressure changes, sudden pressure changes, reactivity changes with the temperature. Therefore, electrochemical sensors are highly temperature dependent and operating them at a right temperature range can improve their sensitivity and stability. Gas flow control. Optimize the gas flow rate to ensure consistent gas exposure to the sensor. That means in the wherever we want to apply the make sure that there is a steady flow of that gas so that any changes in the oxides of nitrogen it can be detected easily. If there is no gas flow towards the sensor, then it is very difficult to give the accurate result. Okay, so if a right gas flow control is there, then it will increase the response time and accuracy of the sensor. Packaging, a proper packaging of the sensor can also prevent the contamination and increase its durability and to maintain its performance. Should not simply keep it open in the atmosphere. If you are not using also, it should be properly packed and kept. Please do subscribe to my effort on bringing this type of videos thinking about the future next, what you want to study, how you can improve your basic knowledges on sensors. Support me to my YouTube channel, my intuition 4865, myself Dr. Prasad Puthiyillam. Once again, thanking you all for being with me. Thank you.